Okay, section 4.2, trig functions in the unit circle. This page has all of the special radians and special triangle locations on the unit circle. Normally it wouldn't be two separate circles, right? It would be one circle with all of these lines on it. If you were following the video, these are the ones that are, these are the ones that are yellow. These are the ones that are blue. And then the axes end up green because they end up used every time, and yellow and blue make green. So it is very important that you learn how to draw these unit circles on your own because you will not be given one on test day. Okay, where different trigonometry ratios are positive. So we have our quadrants, and you should be learning by now, this is quadrant 1, 2, 3, and 4. It goes counterclockwise just like the unit circle does. In quadrant 1, they are all positive. That's what the A stands for. So on the side there's a key, right? In quadrant 2, sine and its reciprocal, cosecant, are positive. In quadrant 3, tangent and its reciprocal, because when you flip something over, it doesn't make it negative. So tangent and cotangent are positive. And in quadrant 4, cosine and secant are positive. We have a little mnemonic device to help device to help us remember that. It is all students take calculus. Feel free to make up your own, but this is one that you will hear many teachers use. We were taught it and we continue to teach our students it. So if you're in quadrant 1, they are all positive, sine in 2, tangent in 3, and cosine in 4. So we are going to find all 6 trig ratios that satisfy theta equals negative 3 pi over 2. Remember that video not too long ago when I told you we were staying in quadrant 1, but we won't be staying in quadrant 1 for long? Now we are officially out of quadrant 1. So first you need to figure out where negative 3 pi over 2 is. So maybe you want to convert it to degrees. Maybe you can figure it out without doing that. See if you can find the point on, remember this is always a circle, but we don't draw the circle. Find the point that would represent negative 3 pi over 2. Counterclockwise, 3 sets of 90. This point would represent negative 3 pi over 2. It's also the same thing as pi over 2. Maybe if you didn't like it, you should have added 2 pi to it, and then you would have gotten pi over 2 and found a coterminal angle, and that would have been the same location. So based on that spot, see how many of those you can answer. So remember, we've got our unit circle, right? Up there, that is 0, negative 1. Because the radius of a unit circle is 1, where'd negative come from? It's gone 0 left or right, and it's gone up 1. Also remember, x is cosine, so it goes cosine theta, sine theta. So that's x, y. So the answer to cosine is 0, and the answer to sine is 1. Also remember, tangent theta is y over x, or sine over cosine, depending on what you've got. So tangent is going to be 1 divided by 0. I'm going to write it here for 1 second, right? Y over x, sine over cosine. But that is undefined. Does not exist. We call it undefined. It's very important that you call it undefined when we're doing trig ratios. Now I flip them all over for cosecant. Sine is cosecant upside down, or cosecant is sine upside down, which is still 1. When you flip 0 upside down, you get undefined. And when you flip undefined upside down, you get 0. And I hope you can see why based on this fraction I wrote right here. If I flip that over, I get 0 over 1, which is just 0. Cotangent of pi over 2 minus theta. Do we remember what this pi over 2 minus theta means? That's the complementary co-function. So instead of cotangent, I could just answer tangent of regular theta. And tangent of regular theta was answered up above. The answer is undefined. I could write that here. The answer to the question is undefined. Okay, let's try another one. See if you can figure out where 19 pi over 6 is on your unit circle. So this one might be a little harder. You might want to do coterminal, right? 19 is bigger than one trip around the circle. So if I subtract 2 pi, which is the same thing as subtracting 12 pi over 6, subtracting, not equaling. I did a common denominator. 19 minus 12 is going to give me 7 pi over 6. So hopefully you can figure out where 7 pi over 6 is. It's a little more than 1, right? 6 pi over 6 would be pi. So it's a little bit further than that. The pi over 6's always are, I should use a straight line. The pi over 6's are always kind of clinging to the x-axis. They're really close to the x-axis. So this point on the unit circle is 7 pi over 6. Can you remember what the coordinates are there? You know, you could draw a unit circle on test day, or you can start being able to think through it, right? When it's closer to the x-axis like that, the x value is the bigger number. Also, it's left, so negative root 3 over 2. When it's really, really close to the x-axis, the y-axis is the really small number, but it's also down, so negative 1/2. So then, which answers do you know? So, cosine, sine. So cosine is negative root 3 over 2. Sine is negative 1/2. Remember, tangent is sine over cosine, or y over x. So negative 1/2 over negative root 3 over 2. First of all, I see two negatives. Those go away, right? I keep the top, and I flip and multiply by the bottom. Oops. The 2's cross out. I get 1 over root 3, but special triangles, root 3's and root 2's, are the one time you must rationalize. So I can't leave it with a root 3 in the denominator, so I need to multiply by root 3 over root 3. I get root 3 over a regular 3. And chances are you will do that enough that you start memorizing reciprocals. Rationalizations. So tangent of theta is root 3 over 3. Now I just got to take all of these and flip them over to get the reciprocal functions, right? Negative 1/2 flipped over is still negative 2. Cosine, I need to flip that over, so I'm doing secant. I know it's negative 2 over root 3, but I have to rationalize it. So multiply by root 3 over root 3. You get negative 2 root 3 over regular 3. Cotangent, I could flip it over, but remember over here when it was 1 over root 3? That is the same thing as root 3 over 3, right? We made these are equal. This is an equation all the way across. But this one is easier to flip over. If I flip that over, I'm just going to get root 3. If you did the work with 3 over root 3, rationalizing it, you would end up simplifying it down to root 3 as well. Can you figure out what secant of pi over 2 minus theta is? Complementary co-function. Secant does not have a co in front of it, so that must be the same thing as cosecant of regular theta. Cosecant of regular theta was answered up above. The answer is negative 2. See if you can set up number 3, 11 pi over 6 on the unit circle. It's almost 12 pi over 6, so really, really close to 2 pi. The 6's, again, cling to the x-axis. They are always really, really close to the x-axis. This is 11 pi over 6 radians. What are the coordinates there? So it's a big X, root 3 over 2, and it's a small y, but it's also down, so negative 1/2. See how many answers you can fill in. I'd like you to do the top 4. You should be able to do the top 4 answers. Pause your video. Okay, so sine is the y value, cosine is the x value, sine flipped over is negative 2, cosine flipped over is 2 over root 3, but we rationalized it the page earlier, and I told you might start catching on to what the rationalizations are. It's 2 root 3 over regular 3. Tangent takes a little bit of work. Tangent y over x. Keep the top, flip and multiply. Rationalize. Tangent is negative root 3 over 3. It was positive root 3 over 3 over here. Okay, I want to finish this problem, and I'm going to talk to you about tangent for a minute. So cotangent, flip it over. Remember, this one is a lot easier to flip over. Negative root 3. And then sine, complementary co-function of sine is cosine of theta, which was answered up above root 3 over 2. Okay, this is not mathematically sound, what I'm about to tell you, but it is a nice way to memorize the tangents so that you don't always have to do extra math to find tangent. This is how some of your math teachers can just answer what tangent of, 5 pi over 6 is off the top of their head without having to do any math. So for tangent, if it's something pi over 6, here you go. Are you ready for this? 6 has 2 3's in it, right? It's 3 plus 3. Again, this is not math. This is just how I remember it. 3 plus 3 is 6. That means the answer is going to have 2 3's in it. The only tangent answer that has 2 3's in it is root 3 over 3. You don't know if it's plus or minus until you look at the graph, and I'll help you on that in a second. So if it's over 6, the answer has 2 3's, so it must be root 3 over 3. Tangent anything pi over 3 clearly only has 1 3 in it, so it must be just root 3. Again, you have to figure out if it's plus or minus. And if you haven't caught on by now, anything pi over 4 always comes out to be plus or minus 1. The other ones I expect you to look at. So remember, tangent is the slope of a line. So let me draw a real quick made up problem for us here. Let's say it is, it is down here. Pretend that hits the center, right? I have faith you guys can pretend that touched the center. What radian is down here? Well, it's definitely a something pi over 3, and it's close as you can get to 2, so 5 pi over 3 is down here. You can always go back to your unit circle to check on me. 5 pi over 3 right there. So 5 pi over 3. If I want tangent of 5 pi over 3, you still need to know where it is. 5 pi over 3, there's only 1 3 in it, so my answer is definitely either positive root 3 or negative root 3. Well, now look at the line. Tangent is the slope of this line. Is this line going uphill or downhill? From left to right, it's going downhill, so the answer is negative root 3. Bam, no math. Not mathematically sound, but a nice coincidence that helps us memorize tangent. Moving on. 675. Probably subtract 360 until you get an angle you recognize. 315 degrees lands there. You might want to start practicing with your radians. 315 degrees, if you do the whole pi over 180 thing, is going to give you, where am I at? 7 pi over 4 radians. So same spot as 7 pi over 4. Can you remember the coordinates at 7 pi over 4? And then again, I would like you to do the top 4 answers and then unpause your video. Okay, so the coordinates at 7 pi over 4 are positive root 2 over 2 because it's to the right, and negative root 2 over 2 because it's down. Sine is the answer to, y is the answer to sine, x is the answer to cosine. I flipped them over. I did show you one time over here, rationalizing. When you rationalize root 2 over 2, you just get root 2. When you rationalize negative root 2 over 2, you just get negative root 2. Tangent, can you use the shortcut? Anything pi over 4 is going to be positive or negative 1. Look at this line. Is this line going uphill or downhill? Downhill, so it's negative. Also, you could use all students take calculus, right? In that quadrant, only c is positive, only cosine and its reciprocal. So tangent should still be negative. Flip over negative 1, you still get negative 1. Tangent, pi over 2 minus theta, complementary co-function of cotangent with a t. The answer is negative 1. Okay, Last part is even and odd functions. We discussed even and odd functions back in chapter 2, I believe, and I explained it to you graphically in class. Remember, an even function is if you can fold it on the y-axis, it lands on itself, or if you get the same y value for both x and negative x. I see works in odd. An odd function, graphically, was when you can flip it upside down and it looks exactly the same, or when x changes its sign, y changes its sign. So for trig functions, cosine and its reciprocal end up being even, and sine and tangent and their reciprocals end up being odd. So easiest thing I think you should do is remember cosine is even. Oops, shapes. If you can remember cosine and its reciprocal is even, everything else is odd. So we're going to use this a lot more in chapter 5, but we're going to introduce it right now. So if I know cosine theta equals 1/4, what would cosine negative theta equal? Well, right here, since cosine is even, cosine of theta and cosine of negative theta are the same thing, so it would still be 1/4. Number 2, given cosecant negative theta equals negative 7 pi over, that says 4 on your page, I believe. Mine got cut off. Negative 7 pi over 4, 7 over 4, no pi. I'm stuck on the last assignment. What would cosecant be? Well, cosecant theta, negative theta, is the same thing as negative cosecant theta. So maybe this one needs an equation. Cosecant negative theta is equal to negative cosecant theta. So cosecant negative theta is defined as negative 7/4. But I don't want negative, I already circled it. I don't want negative cosecant theta, I want positive cosecant theta. So divide by negative 1, cosecant theta must equal positive 7/4. So we will use this later, but a little introduction to it today. Hope you guys are doing good.